All right, last lesson of Unit 4. Here we go. We're going to be finding some inverses. But I also know what an important concept this is, and we have done this before. So I have a problem right here. Y equals cube root of quantity x plus 2 minus 1. And just to remind you, finding an inverse is the same every time. Once you know how to do it, it's the same. You switch where the x and the y are. Then you got to get y by itself again. So you start solving for y. So you're peeling some of this information away. And I want to get the problem where I could say, okay, now I'm going to remove the cube root by cubing that. On this side I have x plus 1 cubed equals y plus 2. Now I just have to move that 2 over. And if I do that, I will end up with this other function, y equals x plus 1 cubed minus 2. So this guy, since they did not use f of x notation or g of x, I'm going to mark it as this one is the original here, and I'm going to say this one is the inverse here. If they used f of x, I'd use f inverse x, g of x, g inverse x, etc. But here's the thing with this. I want to remind you that you can always check one of these problems by graphing. Come on, straighten out. Why is that thing doing that to me lately? I don't know, guys. Anyway, there you go. See, it's a trick with this pen. If you hold it still, then it makes it a perfectly straight line, and sometimes it doesn't want to do it for me. Anyway, besides the point, remember, when you sketch a graph and its inverse, the line y equals x, will cut your graphs down the center, so you have a mirror image. So if I were to sketch this graph right here, I could go left 2, down 1, I'd put a dot, and then I'd say, hey, cube root graph, that's the graph that looks like this. And then here's my inverse. I would say left 1, down 2, that would be that guy's locator point for this thing. And then I'd say, hey, you're a cube root graph, so you've got this kind of look to you. Whoops. Hang on, let me redraw that. That wasn't that pretty. So I would say, you've got this kind of look to you. And then I'd say, hey, cool, it looks symmetric. I must have done everything right. It's a way to visually check your answer to make sure it's correct. Now, that might be helpful for you on this section here. But I'm trying to plant a seed. As we go through this, I am always thinking, how am I going to teach you guys everything in 12 weeks? Well, I'm going to wrap around a lot when I have a concept that I know is going to come back later. So here's the thing. For two functions to be inverses of each other, this is a visual way to check it, but the domain of one of my functions, so let's say up here, this guy, well, the domain for that guy is negative infinity to infinity. That guy's domain has got to be this guy's range. Okay? This guy's range. And it just so happens, and I picked on a third power or a cube root for a reason, because cube roots, you have no choice. The domain and range are going to look like that always. Okay? But there was a concept that we talked about being a one-to-one function, and sometimes you have to restrict a function for it to be invertible. Now, I just want to use this time because I got it. I want to remind you, we did those. Those were the ones that look like this, where they gave us something like, and this time I'm going to call it f of x, and they gave me something like f of x equals x plus 1 squared minus 2, something like that. And then I'd say, oh, I could find the inverse for that. I'd call this thing y, but then I'd switch the x and the y. And I'm getting to my point, guys. I am. I just want to take this time to remind you, you've done this. You have seen this, but when I get to this point here, I have to take the square root of both sides. And when I do that, this becomes plus or minus. Rad, and then x plus 2 equals y plus 1. So in the original problem, they would have had to given me some kind of restriction. Because this graph right here, is not 1-to-1. What did that mean back way when? We're just doing a little review here. If I drew a horizontal line, I would hit that graph in more than one spot. So what I'd have to do is say something like, I am restricting you to all x values that are greater than or equal to -1. I'd have to do something like that. Then when I finish off my algebra down here, I'm going to call this result f inverse x equals, now square root of x plus 2 minus 1. I'd still have to make a decision on, is this thing right here going to be a plus or a minus? And this is where the actual graph helped you see that relationship. So I wanted to go through this before we start doing logs and exponentials. So I'm going to draw the graph. And I'm going to draw the line y equals x. Oh gosh, I hope that there's, that's not too bad. And let's go to this first one. I'm going to go left 1, down 2. I got a dot. But remember, here's the restriction that I provided. It's going to be everything greater than or equal to -1. So this would be one of these guys. It's just this side of my parabola. Well, if it's going to be this side of my parabola, that would mean when I graph this inverse here, I'm going to go left 2, down 1. To make this thing look symmetric, I would have to draw this type of graph to make it work, which would mean it's definitely not the negative. So I would want the positive version only to make this work out. But here's where I want you guys to start seeing a bigger picture. Let's go back up here. The way they restricted my original function, the way they restricted it is they said you can only look at the domain from here over, right? You can only look at the domain from -1 to infinity. That's what they were saying. This is called set builder notation or inequality notation. This is stuff we've been using all the way since like the 4th grade when they say the alligator eats the bigger thing. Right? I don't know if you guys were taught that, but this is the alligator mouth and it always eats the bigger thing. You know, but anyway, what I'm doing is when I make a restriction, I'm saying you can only look at this part of the domain, right? Now, what do I know about inverses? This guy down here, this guy's range had better be that. Because if two functions are inverses, one guy's domain is the other guy's range. So let's look at my other dude. I'm just going to grab a red pen for a second. Let's look at this guy. He was what? Left 2, down 1. So if I go like this, remember, range does not care if I'm going sideways, but it does care that I'm going up. So look, where's the lowest point on this red graph? The lowest point is at -1. And even though it does not climb rapidly, it still will climb forever. So you could say that this property of being inverses is met. Now, we're going to talk about logs and exponentials because one of them is the inverse of the other. One function is the inverse of the other. So I made up some examples I want you to go through with me, and you will not see quadratic inverses on this test. You will not see cubic inverses on this test. However, when you guys finally do get to the end of the road here, you will have an AP Calc Summer packet, and this stuff is on it. So I want to make sure that I wrap around and come back to some concepts so you don't lose them. All right, here we go. Now, let's take a look at what we have. We have y equals 5 plus the natural log of quantity x minus 4. Can I find its inverse? And the answer is sure I can. I'm going to take the x and put it there. I am now going to put the y over here. And I've got to get y by itself. Remember, finding an inverse is still the same. You're solving for y. But that means I'm going to have to isolate that piece of the puzzle. So let's get the 5 to go to the other side. I'm going to take away the 5. Then on this side I have x minus 5. What does it equal? It equals the natural log of y minus 4. And then here we go. This is a function with a base of e. So I could use my property concept to get this to look like e to the x minus 5 equals, over here I have y minus 4 now because I'm using a property. And then I would add 4, and I could call my result y equals, call my result y equals e to the x minus 5 plus 4. Now, on your test, I'm just going to tell you, on your test, I will give you either a logarithmic function and you find its inverse, and the inverse will be an exponential function, or I'll give you an exponential function, its inverse would be a log function. So, what if you want to check your answer before you turn your test in? That's what I'm trying to get at. I'm trying to remind you, you guys have a lot of weapons at your disposal. When you guys see the practice problems I made up for this video, I'm going to give you an answer key. But on a test, I don't give you an answer key. It would kind of defeat the purpose of the test. So, if you wanted to check your answer quickly visually, you could do it. You could do it. Let's take this original function up here, and we're going to go, what? Up 5. 1, 2, 3, 4. 5 units up, and then 4 to the right. 1, 2, 3, 4. Which one of those guys is my asymptote? It's the 4 part. This guy is the asymptote. So I am supposed to go 1 unit away from the asymptote, but this guy says, wait, don't do it so fast. Go up 1 unit. Or go up 5 units, and then if I sketch that graph in, it's going to look something like that. Whoop. And then the y part, this guy down here, y equals e to the x minus 5 plus 4. Well, this guy wants me to move 5 to the right, but it's going to change my floor. It wants my floor to be up 4. So if I'm up 4, that means I have an asymptote right here, and I would then go over 5 units to the right, and then I go up 1, and guess what? They both would have that point in common this time, and if I were to sketch my graph, it would look like that, and then here comes the line y equals x. Oh, come on, straighten out. Bam! And it cuts my picture down the middle. So, here's the thing. all of these skills since day one of this class, since day one of our journey. We learned how to graph things based on parent function concepts. It's because sometimes you want to have a good estimate of what the graph looks like. Because here, visually, I can tell that, man, if I was to flip-flop those graphs over that line, that's a pretty darn indication that I did everything right. But I want to add in this little spice of flavor here. Let's look at this original dude, the dude we started with right here. And let's just talk about what would that graph's domain be. Now, I want to make sure I'm looking at the right graph. So, natural log x, that's the guy with this vertical asymptote here. So I would say, hey, your domain happens to be parenthesis 4 to infinity. That is the domain of my original function. So now let's come down here and let's look at my e base function. And when I look at that, this guy's got an asymptote right here. His floor is right there. But I'm not looking at his domain, I'm looking at his range. So see where the floor is? The floor on this function is at 4, and then it goes upward from there. So once again, we're looking for this yin and yang situation. One guy's domain is the other guy's range, and vice versa. I mean, if I went here now and I said, well, what's the range on this one? I could say the range on this function was, and then it would be kind of boring because the range here would be negative infinity to infinity. And then this guy would like, my domain is that. So what I'm trying to say is, whoa, here we go. And I should have color-coded that differently. But let me scroll up. Sometimes when you find an inverse for something, since the domains and ranges are all infinite, like negative infinity and positive infinity, there's not much to really see there. But when they start restricting stuff, then I go, wow, I got a clear-cut starting or stopping point for this stuff. And for this one, heck, if I did want to go through and finish this question off, I could find the range of this guy. I could. And then compare it and go, dang, it's the same as this guy's domain. Totally true, it would be. If you really are curious, you could pause the video right now and verify that yourself. But this is kind of a mix of both worlds. When you find the inverse of a logarithmic function, well, you know that the domain of one thing is going to be infinite or negative infinity to positive infinity. That's not the real tricky or cool comparison you want to make. That's the comparison you want to make. And then you go, you know what? I feel real confident my answer's correct. Okay, I know what you might be saying. If this isn't on the test, do I have to do it? No, you don't have to do it. Would it be a good idea to check your work? Sure. Now here's the other thing. Could you do this on a graphing calculator and check it? And the answer is yes. But some things are much more difficult to punch in on a graphing calculator than they are to just hand sketch. Some things are much easier just to hand sketch than punch in on the calculator. Now I got to tell you, this one would be a nice easy one to punch in on the calculator. It totally would. But I want to warn you, I made up this example so that if you do go to your calculator and punch in this function here, and then you punch in this function here, and then you graph y equals x to split it down the middle, you're going to find out that your graphing calculator is going to stop right here on this function y, and I've said it before. Why is your graphing calculator not going to complete that graph? Because it goes vertical. When your function starts going in a vertical look, your calculator does not know what to do with that information because it cannot think. It can only spit out info. So, I got to tell you, hand sketching is not a bad skill. In fact, it will never go away. You will be hand sketching graphs until we finish this class. So, if you have been fighting me on that skill, stop fighting me on that skill. It will never go away. All right, I'm going to grab a black pen and go down to example 2 here. So here's my second example. Now, I'm going to start you off with an exponential. Guess what? Your answer will be a log. When you start with an exponential, the inverse is going to be a log because they are inverses of each other. So, once again, I'm just going to call this thing x equal 4 plus e to the y plus 2. And then I'm going to move the 4, and I get x minus 4 equals, then over here I got e to the y plus 2, but if I want to get rid of that e base thing, and I want this guy here to come down, I would have to do natural log of this side. Look, that's a property. Natural log of e to the power means I can bring the power down, and then what happens? Natural log of e, that's gone. So I get y plus 2 on this side. But if I do it to that side, I got to do it to this side. Now, when I say this side, if I do this and I write it like that, I am going to get it wrong. I'm going to be incorrect. See, if you're taking the natural log of this side, there's a monomial base. But if I take the natural log of this side, there's two things there. It's a binomial. So be very cautious with your thinking when you are operating on these functions, because log is still a little bit relatively new and unique to us. So when we start messing with it, come on, pen. When we start messing with it, we got to be cautious. And if I had made a mistake when I went to graph it, I would totally see it. It would be very highly visible, and the domain and range trick that I showed you would not work out. So here, I'm just going to do this real quick. We're going to do x and y. Come on. I already know that I need the line y equals x. Oh, God, that was really crooked. Okay, the thing fixed it for me. And let's go with this one. Let's graph this guy. We're going to say, hey, guy, I'm going up 4, it looks like. 1, 2, 3, 4. And then they want me to go left 2, and then 1 unit above my asymptote would be that locator point. And I would say this graph should look like this. All right, that's what it should look like. Let's graph this one here. Let's graph its inverse. Well, this guy has a wall at 4. So it's got a vertical asymptote. And then it tells me, hey, before you go 1 unit over from the asymptote, before you do that, go down 2 units before you do that. And then this sketch would look like this. And then if I were to examine that, I'd say, you know what? This line, y equals x, seems to cut my graph right down the middle. So visually, this is very appealing to me. Now, if I look at the original is exponential. The inverse will be logarithmic and vice versa. All right, I want you to keep that in mind. Write it in your notes. If I start you with an exponential function, your inverse must have a log of some kind in it. And if I start you with a log function, your inverse must have an exponential in it. Now, here, if I look at the domain, like I said, this is what I was trying to allude to at the other one. The domain for this thing is negative infinity to positive infinity. Well, guess what? That's what the range of this dude is. That's true. But it's more helpful when you look at the comparison here. This guy's range, this dude's range, is from 4 to infinity. And then this guy's domain This guy's domain is from 4 to infinity. All right, you could do that on a graphing calculator, but you got to be careful because right about here, your calculator's not going to draw the rest of this graph in, and it's going to look weird because it won't look symmetric because the calculator will chop off the vertical part where it starts getting asymptotic. Be cautious. Anyway, on the test, I give you this, you give me that. You show me this. This is the work that I expect to see when you go from one to the other. Now, some people get kind of cocky and they say, I noticed the pattern. Do I really have to show the work? And I say, well, what are you going to do about this one? And then they go, yeah, I'll just use the pattern. Here's the problem. That little negative there will mess with you. It will. So I always tell people, if you're going to guess based on actual evidence and work. You know, don't just guess and hope you're right, because it's not a good look. It's not a good plan. So here we go. This time I used function notation. I used f of x. All right, so technically when I get to the end, my answer will say f inverse of x equals, and then whatever that is. So let's call this thing, I'm going to call it y equals. So when I switch the x and the y, it doesn't look weird. So I'm going to say x equals -1 minus 6 to the y plus 2. I am now going to try and isolate the part that has the variable. I am. So I'm going to add 1 to this side. I'm going to add 1 to this side. I'm going to get x plus 1. What's it equal? It equals -6 to the y plus 2. But you know what? Here's the dealio, yo. This technically means -1 times that. That's what that technically means. I don't know if you guys remember this from very first lesson. Your base value has got to be greater than 0. So having a base of -6 is not valid. But it doesn't mean you couldn't have a negative times your base. And that's what you're actually looking at here. So how do we get rid of this? Well, we could either think of it as divide this side by -1, divide this by -1. You could think of it that way. Whoop, come on. Or, I was going to erase this. Or, some people prefer to think of it this way. What if I multiplied, since it is an equation, what if I multiplied everything by -1? What if I did that? Well, then this whole side here would get negated. And this side over here, the negatives would cancel, and I would achieve that goal. I don't care how you see it or how you visualize it, but what I do care about is you see that this is the result over here. That's what I care about. Because if you don't get that part right, that will cost you. And it will not look right when you try to graph it. If you were going to try and graph what this looks like, you're not going to be successful. So, let's continue. I am going to take away my little squiggly line because I'm about to do this. I'm about to say, you know what? I'm going to take this entire side, log base 6. Here I'm going to do log base 6. And why would I do that? Because my property on this side, my property says you get y plus 2. What's it equal? Log base 6 of this stuff. And then I'm going to just move the 2 over. And I get, well, let's write it in F inverse style. I get F inverse is log base 6 of -x minus 1 minus 2. Bam. I started with this. I ended with this. Now this one, I'm telling you, would probably be kind of tricky to punch in on your calculator to check it. You'd have to be real cautious. Because on the calculator, if I want to graph this part right here, if I want to graph this part right here, I'd have to enter it in. I'd go to my y equals on my calculator, and then I'd have to say log parentheses negative x minus 1, close it, divided by log 6, close it, minus 2. That's how I would have to punch that in on my calculator to make it graph this correctly. I mean, you know what? Let's give it a shot. If you graph this one, just remember you're going to have to graph the other one, which was your original, which is up here. And if I do that, you got to also understand that these graphs are going to get flipped around and things like that. And you know what? I got my graphing calculator right here. I am going to punch this in just for kicks. Now, you can't see me actually punching in these keystrokes, but I'm just curious to see what this will look like when I do it. So I punched in the original, but you know what? I just realized when I did it, I'm in classic mode. So in classic mode, I have to put that part in parentheses, or it will lie to me. Oh no, dog, don't bark. And then down at the bottom, I'm doing log parentheses of negative x minus 1, not negative x negative 1. But I have to say divided by log of 6, close the parenthesis, and then minus 2. And then don't forget the third graph you always have to draw is y equals x. And I don't know if I zoom standard in a while, so I'm going to zoom standard when I graph this. And I'm taking a look. So far, so good. But you know what? This is what I was afraid of. When you do not see that graph going vertical all the way down, it really plays with your mind. So this is why I warned you. If you punch this in on the calculator, you're gonna see this. You're gonna see what I'm talking about. So hand sketching sometimes is the way to go. Now, like I said, I'm not going to make you hand sketch everything, but let's graph the first one. Let's graph this guy here. So I'm going to go down 1. This guy's got a floor. Got a floor at negative 1. I want to go 1 unit above that floor, but wait. No, I don't. This graph has been flipped downward. Since it's been flipped downward, I'm going to go 1 unit below the floor. And then this part right here says, wait a minute, go this way 2 units, then count 1 below the floor, and then sketch your graph. And then the other dude down here, let's graph this guy. See, if I want to graph this one, this is the part my calculator messed me up on. This guy has a wall at negative 1. See, you're setting what value would I have to plug in here to make this whole thing 0? It would have to be a negative 1, because then it would be a negative 1, that's 1, take away 1, that's 0. So you might want to be super cautious when you do this, because that guy right there is going to be a sideways flip also. So instead of going, well, it wants me to go down 2 also, so I'm going to go down 2. But instead of going 1 unit to the right from that asymptote, I'm going to go 1 unit to the other side. And I have to remember my asymptote's right here now. So when I go down, it's going to go like that. And here's my y equals x. Oh, come on, really? That's horrible. Yay, it's straightened out. So there you go. Huh? Pretty rad. I think that's a pretty rad picture myself. Anyway, this is the part that your calculator could not draw in for you. So when you look at it, you go, gosh, is it right? Is it really right? All right. from day one, I've been preaching the same skills because in math, we just keep building. Now, just to hammer it home one more time, the domain of one should be the range of the other and vice versa. But let's move on because I have two more examples, because the ones that have negatives in them can be, oh, and you know what? I wanted to mention this too. Hang on before I go to the next one. Log base 6. You know what? A base 6 means the base is greater than 1. So I know that bases greater than 1 behave different than bases that are less than 1. Okay? Because I didn't teach you how to graph this parent function style, but you guys should know, based on the fact that you've graphed so many exponential functions for me now, you got a vibe for how they look. So that's why I wanted to show you in comparison. What about this guy? What about this dude here? Well, could I switch x and y? You better believe I could. And then I could say, you know what? I got to get rid of this log thing, so I'm going to do this trick. You know what? I'm going to make a big old base. I'm all about that base. So what would happen over here, kaboom, I have 1/4 to the x equals y minus 3. I'm going to move the 3. So my new function here is y equals 1/4 to the x plus 3. Now be careful, because if you want to check this on your calculator, also, if you're in classic mode, you're going to have to lock this thing up. But in math print mode, you're going to have to remember to move back down before you add the 3. So, I mean, using your calculator, you got to know your machine, because it's not going to think. It's just going to spit stuff at you. So, hey, remember, if I were to sketch this thing out, I'm just going to do it real quick, because this guy has a wall at 3. 1, 2, 3, got a wall. And then it's a fractional base. So I'm going to go 1 unit to the side here, and this fractional base makes it swoop down this way. Whoop, this way. That's what this guy's job is. Okay, well, what do we know about exponential functions that have a base value that's less than 1? We also know that those are called decay graphs, not growth. But this one's been moved up 3. 1, 2, 3. And then I go 1 unit away from the asymptote, because there's no monkey business here. But it's a decay graph, so it's going to come from the top, and it's going to go down like that. And then my line y equals x. Oh, please straighten out. Thank you. See? And I extend that a little bit so it looks prettier. Right? Put an arrow here because it's infinite. And then we go, dang, that's a pretty looking picture too. All right? But I didn't teach you how to do these parent function style, but I did teach you one thing. If you got a log that's base is less than 1, it swoops down. If you got an exponential whose base is less than 1, it's decay. So you can make a good estimate. Remember, parent function style graphing is a rough sketch. You try to make that sketch as pretty as you can, but you are not making a big table of values to do it. You're not. All right, I'm going to stop hammering on this concept, but one last time, look at my original function. One last time. What's this guy's domain? This guy's domain would be 3 to infinity. Look at this guy's range. Look at this guy's range. It would be from, range from 3 to infinity. It would. One guy's domain is the other guy's range if you're doing this right. All right. So, let's look at this one. because it's got a negative here, which means I'm going to have some kind of difficulty I've got to be ready for eventually. All right, and they said g of x, so when I get to the end, my answer should say g inverse x equals, and then whatever it is. All right, so I put the x here. I put the y there, but I don't switch the negative, I just switch the letters, so the negative stays with the y. But now I'm going to take away, and I'm going to get x minus 2 equals log base 6 of negative y. That's what I'm going to get. And then I'm going to say, wait a minute, how do I get that log base 6 out of there? I go exponential on it. I could say base stays the base flip-flop, or I could use this trick. They both result in the same thing. That guy's gone. So what do I end up with? 6 to the x minus 2 equals negative y. Well, I don't want negative y, so here's where I'm personally, I like doing this. Oh my god, this is the worst looking bracket. I'm going to multiply both sides by negative 1. I'm cracking myself up because that was so crappy. And what do I get? I get g inverse, because I'm going to call it g inverse now. And it's a negative 6 to the x minus 2. Now, technically, that does not make my base negative 6. It doesn't. It means I got a negative times the base of 6. But it would definitely cause this graph to flip. And this graph would also be flipped. But one of these guys has a top to bottom flip based on its negative location. One of these guys has a side to side flip based on its location. All right, so I don't want to go through one more graph because I want you to. Here's my evil plan. Ready? This is lots of examples, but I just want you guys to try this one. Here's f of x equals negative e to the x plus 2 plus 1. You try it and check it by sketching the graph. I would like you to pause the video right now, try to do it, try to sketch it, and then after you've got an answer and you've got a picture, I want you to come back and see if your answer matches mine. Okay, so pause it and try it, please. I'm assuming you paused it and tried it. And if you didn't, oh well, you should. I'm only trying to help you get better at math. But here we go. Here's the answer. Look at that. I did it color-coded. It's all pretty. I wrote it out on paper too, so I could highlight it. There's the original, f of x. There's the answer, f inverse x. All right. I hope you got it right. And if you don't, you know what? This is why you guys got to come back to my Zoom room, because I never leave it. Remember, I'm always sitting there. I really am. I'm in my chair. I'm making up more problems for the next unit or examples. You know, these videos don't come with pre-made examples. I have to make them all up. So, guys, I'm always doing math, help trying to get the next thing ready for your mind. So, if you did not get this right, and you have questions about any of my previous examples, please jump back in the Zoom room and ask me, because this is your practice coming here. Let me show you. All the way to the top of the page. Yeah. See how it says log and exponential inverses? What? Playa. Here we go. Look at all those. There's a bunch of different ones. Do remember, when you start doing this, it says find the inverse for the following exponential or logarithmic functions. You could sketch a graph and try to check it on your own. You could even use your graphing calculator. Just be aware of the vertical asymptote problems. But in this case, it is a worksheet. It is a practice sheet with 10 questions. So here's my answer key. Now, I was I didn't think about this until after I wrote it down, and I didn't want to write this down twice. Some of these should say y equals. Some of these should say f inverse equals. Some of these should say g inverse equals. But you know what? Those are the correct answers. So make sure you're matching up with me when you go through this. Alrighty, guys. Good luck to ya, and jump back in the room if you need help. I'm always there. Bye-bye.